Hello, I'm Patty Simpson with Simpson Math. Let's look at sample spaces and symmetric sample spaces. First, we have an experiment where we roll a six-sided die. Let's create just the sample space of that experiment. Remember, a sample space is just the set of all outcomes that are possible from the experiment. So if I roll a six-sided die, I could roll a 1, I could roll a 2, I could roll a 3, I could roll a 4, I could roll a 5, and I could roll a 6. So the sample space of rolling a six-sided die is 1, 2, 3, 4, 5, 6. Those are all the possible outcomes. Now we ask ourselves, is each one of those equally likely? Is each one of them have the same probability as the next? And it's just as likely as I roll a 1 as I roll a 6. Each one of them just shows up one time on my six-sided die. So therefore my symmetric sample space looks exactly the same. 1, 2, 3, 4, 5, 6, because each one of these outcomes is equally likely. So in this case, for this experiment, my sample space and my symmetric sample space are identical. Let's look at the experiment of tossing a coin and rolling a six-sided die. In this case, I'm going to toss a coin, and it could land on heads or tails, and then I'm going to roll that six-sided die, and where I could get a 1, 2, 3, 4, 5, or 6. So what are the possible outcomes? Well, it might be easier to draw a tree for these two. And so on the coin, I could get a heads or a tails. I'm going to draw a sideways tree because I don't have a lot of space here, but I could get a heads or a tails. Those are my two outcomes for tossing a coin. Then I'm going to roll a six-sided die. So if I got a heads on my coins, I could get a 1 on the die. If I got a heads on the coin, I could get a 2, or I could get a 3, or I could get a 4, or I could get a 5, or I could get a 6. So there are 6 different possibilities that I could get if I get a heads first. I could get a heads and a 1, a heads and a 2, a heads and a 3, a heads and a 4, a heads and a 5, a heads and a 6. What about if I get a tails first? Well, if I flip the tails first, I could still get those same possibilities on my dice, where I'm getting a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possibilities for if I flip the tails as well. A tails and a 1, a tails and a 2, tails and a 3, tails and a 4, tails and a 5, and tails and a 6. These are all the possible outcomes for this experiment of tossing a coin and then rolling a six-sided die. So this is my sample space. Now let's look and see if each one of those is equally likely. Each one of those shows up exactly one time, so it's just as likely that I get a heads and a 2 that I get a tails and a 2. Each one of them has the same likelihood. And so this is both my sample space and it is my equally likely sample space as well, my symmetric sample space as well. Let's look at if I have 3 children. I decide I want to have 3 children. What are my possible outcomes? Well, let's just look at the sample space for a second. I could have, if we think about my options, I could have all 3 boys. So 3 boys is one possibility. Another possibility is to have all girls. So I could have 3 girls. Maybe I just have 1 boy and 2 girls. So another possibility is 1 boy and 2 girls. And then the last possibility is 1 girl and 2 boys. So I could have 1 girl and 2 boys. So I could have 0 boys, 1 boy, 2 boys, or 3 boys. So those are my possible outcomes, my sample space. Is it equally likely that I have 3 boys? Is it just as likely I have 3 boys as I have 3 girls? Do those have the same probability? Well, we can make a tree diagram to help us see. If, like here, they each show up 1 time, then we will know that they are equally likely. So let's make a tree diagram to show those outcomes. So here, the first child that we have, on the first child, I could have a boy or a girl. So I'm going to show that using this tree diagram, that I could have a boy or I could have a girl. Now, on my second child, if I had a boy on the first one, then on the second one, I could have a boy, so that I have a boy and a boy. Or if I had a boy on the first one, I could have a girl on the second child, so that I have a boy and then a girl. Well, what about if I have a girl first? Well, if I have a girl first, then I could have a boy next, so that I had a girl and then a boy. Or I could have a girl and then a girl. So this is all the outcomes for if I have two children. I could have a boy and a boy and a girl and a boy, or a girl and a girl. Those are 4 different outcomes there for having 2 children. Then what about on the third child? Well, here I have a boy. So here I had 2 boys. Well, on the third kid then, I could have either another boy, so that I end up with 3 boys, or I could end up with a girl. So what have I had? Well, I had a boy and then a boy and then a boy, a boy and then a boy and then a boy, or I could have had a boy and then a boy and then a girl, boy and then a boy and then a girl. Here I had a boy and then a girl, so what could happen on that third kid? Well, I could have a boy or I could have a girl. So in this case, if I had a boy first and then a girl, then I ended up with a boy, girl, boy. Here I ended up with a boy, girl, girl. Now, that's all my potentials for if I have a boy first. But what if I had a girl first? Well, I could have had a girl and then a boy, in which case, then I could have a boy or I could have a girl. So another option is to have a girl, a boy, or to have a girl, a boy, and then a girl. And then last but not least, I could have a girl. Well, if I have a girl and then a girl, I could end up with a boy, or I could have all 3 girls. So a girl, a boy, or a girl, a girl. So now let's look and see, is it equally likely that I have all boys? Does that have the same likelihood as having 1 boy and 2 girls? So let's look and see, 1 boy and 2 girls, how many times does that show up? Notice that turns up actually 3 different times. So it's more likely that I end up with 1 boy and 2 girls. That's more likely than for me to have 3 boys. It's more likely that I'm going to have 1 girl and 2 boys. That's more likely than me having all 3 girls, because there's only one way for me to have 3 girls. So this is my sample space, but it's not my symmetric sample space because they're not equally likely. In order for it to be an equally likely sample space, I would have to show all the different outcomes here, so that this whole thing is my symmetric sample space. all of those are equally likely now. Now it's just as likely I have a boy, a boy, a boy. That's just as likely as me having a boy and then a boy and then a girl. That's just as likely as me having a boy and then a girl and then a boy. So this is my symmetric sample space, or my equally likely sample space. Now, symmetric sample spaces are really important to find, because it turns out that probability and area are related. So if we can find this symmetric sample space, it really helps us to be able to see or find the probability of different experiments. Math Made Simple is Simpson Math. Thanks for watching.